Okay, so uh, let's look at the next problem in theory of computation. Which of the following are regular sets? Okay, so we are given these four sets, and we have to tell that which of them is a regular set, and then you have to correct these. You have to choose this correct option down there. Okay, so regular sets. Okay, we all know that regular sets are the sets that are accepted by a finite state machine, okay, a finite state automata. Those are regular sets, and for non-regular sets you need a more powerful uh, system, or a more powerful automata like push down automata or higher ones. Okay, and and if we can construct NFA for a set, that means it can be accepted. Okay, so that's what we are going to do. We're going to look at them one by one and see if it is regular or not. So the first one is this thing. Okay, so A is, so you have A n times A, and then you have 2m times B. Okay, this 2m indicates that B is even number of times. Okay, 2 times of anything is even. So this is any number of times and this is even number of times, and there is no relation between them. This n is no way related to this m out here. Alright, so with that thing in mind, what you can do in this case is something like this. Okay, uh, okay, so I start here like this. Okay, I can definitely accept empty string. For when n is 0 and m is 0, it is an empty string. Okay, and then I can keep on reading A's and I keep on accepting them as many times as I want. So this is for A, and then I can make this transition from here to this another state. Okay, like uh, on reading, let's say I make an E moves, because I don't need a DFA, right? I don't have, it doesn't have to be deterministic for regular, it can be non-deterministic. So let's say I make an E move out here and I came here, and then what I am going to do is I'm going to say that okay, this is again my accepting state, and if I read a single B, I go somewhere here which is not accepting, and if I read another B, I come back and this is accepting. So what happens in this case, you can read as many A's as you want and be in the final state which will be accepted, and if you want a concatenation of B's with that, as you have in this case of 1, if you read only one B you don't accept, but on second B you accept, third B you don't accept, fourth B you accept. So what you get is even number of B's get accepted, which means that A is, this one is indeed a regular set. Okay, and what about the second one? The second one is there is a relation between n and m. So this is A n and B m. So that means that the number of A's should be equal to number of should be 2 times number of B's. N is equal to 2 times of m. Now this cannot be done with regular set because it needs counting. Okay, and you need a stack to do this, and a regular set doesn't have a stack. You can do it with a push down automaton. This is a classical example also of a non-regular set that you always see. So you cannot do it with regular set. You can prove it by pumping lemma. The standard way to prove that something is not regular is pumping lemma. Okay, but I'm not going into that because then I'll have to describe what pumping lemma is and prove and give a long proof, which will take like a lot of time. So instead what I'm going to give you, this thumb rule, is that if whenever you need counting, whenever you need to keep track of what you have counted, you need, it's not going to be regular. You will need a stack or something higher, maybe a Turing machine or something. So out here how you will do it is basically like this. So you will have a stack. As you keep on reading A, you will keep pushing some symbol in the stack, and when you start reading B's, since you need only half B's. Okay, so because number of A's is it's 2 times the number of B's that you see. So when you start popping off, you pop 2 at a time. On reading 1B you pop 2 at a time. Okay, I'm still like kind of digressing from my main point, but yeah, so the main point is that this is not regular. You need to keep track of counting. It's not regular. Third, okay,
So this is again the same thing. You need to keep track of counting that the number of A's you have seen so far and the number of B's you have seen so far are not equal, because out here it is A n B m, n is not equal to m. So it's just the complement of these things, and so it's you need a stack, okay, for these things, because you need to keep track of countings. This is not regular again. What about the fourth one? It turns out that fourth one can be done with a finite state machine. So what you have is x, you have c, and you have some y. So x can be anything in this a comma b star. So what you can do is you have this thing, all right, and you can read as many a's comma as many b's. Okay, this will take care of this a comma b star. And then you read C and you move to this other state, okay, and then you can read as many A's and as many B's and make this a final state. So this way you can do the fourth one, okay. It can be done with a finite state machine, and that means only 1 and 4 are regular, so option A is the correct choice.